Hello everyone, I'm a PhD student in a public university and today we will be looking at another chemometric examples such as classification. So today we have a data set that includes obtained powder data from different relative humidities and we're going to start to make some classification. So let's try to do it. So what we're going to do, first we're going to look at our Excel file. We are going to import it to the program that we are going to use, which will be Orange in this case, and we will make a preliminary analysis. We will first check the PCA if we could see some groupings, and then we will go through for different algorithms like KNN, K nearest neighbors, classification trees, and support vector machines, which is a machine learning algorithm just as classification trees. So let's start for today's topic. Okay. So for this time, we have different type of data. We have NIR data. The range is from 2500 nanometers up to 1000 nanometers. So we have a different kind of measurement results right now, and we will be checking them. So as you can see here from the left side, we start with the target. The target is actually the value that we're going to try to fit. In this case, it will be our classification results. So those are relative humidities, different relative humidities prepared before by using desiccators. So we're going to try to predict them with our new algorithm. So in here you can see the labels. We have replicates, we have different samples. In here you can see different kind of spectra. And those are the response data that we have, which means that they are the absorbances obtained for different wavelengths by using a benchtop NIR device. Okay, now we have our data in here. We can close this data. We don't need to make any changes. And we could open Orange, but I've already opened it, so let's go through that. From File, we again selected the sheets and the data. Okay, we can say that, okay. But for this time, the thing that we need to make, we are going to make a classification, so our type of variables should be categorical. If we were to make a calibration, which is also regression, our target data type should be numeric. Okay, so this is again our target, and all of other things are the features, which is variables, and you can also say factors. So we have labels, spectra, that's okay. The first thing should be checking the data table. Let me bring it for you. In here you can see the data table. We have our targets. You can also filter them. You can rank them according to their levels. And that's all. Okay, and in here we can add preprocessing, but we will first check without any preprocessing. There are some preprocessings in here, but I would like to show you first our spectra. So how our spectra looks like. From here, it is very hard to comment on raw spectral data, but anyway, since we have an NIR device right now, it is more informative than visible in terms of separation of the chemicals. Let's say some specific bonds, at least we have second overtones of, for example, CH bonds. For other bonds, we can make some small comments in here. So what you see here is different type of relative humidity values for different samples. And you can see here, even from here, just by looking at the raw spectrum, we can have some guesses. For example, the 90 falls below. And then as an increasing order, we have some kind of a pattern in here. As we increase in absorbance, what happens? The relative humidity decreases. So this means actually if we have more water in the sample, that means our absorbance values will increase. There are also water absorbance bands in NIR which explain this phenomena, but just by looking at raw data, we have now an opinion. Of course, it needs some preprocessings, maybe baseline corrections, maybe smoothings, and then after that we can make our final comments. Okay. So the next thing is, after checking the spectra, what we do a simple PCA. With the preprocessings that we apply, let's check the preprocessings. Actually, we can do it, let me talk about this a little bit. this shows us if you use one component, you have 98% of explained variance, which is very high. But if you use two components, you have 99%. So the second component is a contribution of 0.01%. What this means, when you are making like big comments, maybe thinking about that the second component has a very low explained variance. Of course, it could have a very rare chemical, it could have something that has very low amounts. We should still consider it, but just keep in mind that low values of explained variance, it could be some kind of an error. It could be some kind of small changes in the environments, in the lighting, so we need to consider that also. While we are making bold comments, we should maybe not include that small explained variance components in the PCA. Okay, let's check the scatter plot, which shows PC1 and PC2. So what we see here is very interesting, guys. You see there are groupings, and they are meaningful groupings. So what it shows to us, let me just make it smaller. You see, when you look at PC1, which has the highest explained variance in terms of score values, you see as PC1 increases, the relative humidity also increases. And we see specific groupings in here. For example, let's check those samples, like precisely measured. And then also we have those groupings which are 43, we have those in 75, we have those in 60. So we basically can say, just by looking at the PCA, now we have clusters, different samples clustered together. So that means that maybe using this kind of device, using this kind of technique, separation of different relative humidity powders could be highly possible, because we see groupings. But this is not classification. I'm just saying, I'm warning you, this is just a preliminary thing. This is just a preliminary dimensionality reduction approach to see your data, if there are any outliers, if there are any problematic things. So this is basically that. And when you look at that blue parts, they're all zero, but you see they're different. Actually, we know the reason. It is most likely by keeping them into different relative humidities. What we did, we used same desiccators for all 25, 43, 60, 75, and 90 samples. But for 0 samples, we used 3 different desiccators. So this is the reason that kind of a, let's say, mislead, that kind of a so this is that kind of a scattering that you can see in here. So this could be the reason of that high difference when compared with others. Okay, after looking at PCA, now we will actually go to test and score our algorithms. But first, let's check different preprocessing of the spectra. What I do in here, one of the good sides of this program, I open both windows and I compare them. For example, what happens if I lose normalization? You see the PCA changes. Actually, this graph is a graph that I like to comment on more. You see, when we just lose the normalization preprocessing, it's scattered a lot. So we have different deviations. We have, again, some kind of clusterings, groupings, but they're not that obvious anymore. Let's lose the cuts. You can do a lot of things in here, but first thing was, since we get the transmittance data, we wanted to transform it to absorbance, just to start with. And then we include, let's say, normalization. We include, generally, I use standard normal variate because for food samples, this is one of the best performing ones. So you see the groupings are getting better now. Okay. Another thing that we can do, we can add Savitsky-Golay to smooth, but I would generally choose to add Savitsky-Golay to just before normalization, just to smoothing. I choose 15 window. While you're choosing the window size, the amount of variables is important. Please try to not exceed the 10th of your variable number. Okay, so with 15 intervals and with other data, you see our data is getting better now. We have better results, basically. What you can do, you can also add a lot of like Gaussian smoothing, normalization, integrate, PCA denoising. We will have another video that we specifically talk about preprocessings, so I will not be getting into too much detail. Let's close that. Okay, after looking the PCA, now we can go to classification algorithms. So I used KNN, I used trees, classification trees, and I used support vector machine. Basically, those are the results. If you see high precision, if you see high accuracy, classification accuracy, and recall, they're good signs. Again, we will have another video that is talking about the parameters that we are gonna dig into. For this time, we will just focusing on the practical approach, but seeing high values of precision recall is important. So what we did, just to start with, we made a cross-validation, which is actually quite important because before, like just in the previous video, what we did, we we made separate test and train sets. But just for overall opinion, what you first do, you make a cross-validation, which is easy for you to compare the results, just to see the preliminary results. It's a very good performing, let's say, sample test train separation tool. And in here you see KNN, tree, support vector machines. Well, the best performing one is support vector machines. As you see here, it gets very good results. Generally, machine learning algorithms could perform better, but there is always a risk of overfitting, especially if you have few data. Please be careful while including machine learning systems. It is very important to consider the overfitting also. So let's close that. And you can also change the parameters. What we can see from here, we can see confusion matrix. You see, what confusion matrix tells us that the actual measurements and predicted measurements for support vector machine, all of the samples, for example, predicted correctly. But for classification trees, one of the 25s were actually classified as 0. One of the 43s is classified as 25. Those are the errors that we have. Those are the mistakes that the algorithms do. But for a data set that have 51 samples, those are very few rates, and the purpose of this work is most likely fulfilled with those results. Okay. Thank you for being here. Thank you for listening. Have a nice evening.